My name is Zeller. I'm the science director with the Blue Ridge Environmental Defense League. We were founded in 1984. We have chapters in 7 states, and nearest one to this spot would probably be either Chester County, South Carolina, or perhaps York County. We also have other chapters in the Palmetto State. I'm here today to speak against this proposal. Blue Ridge has weighed in with administrative legal actions for the last several years, and much of what we have learned has come from talking to technical experts, nuclear engineers, other experts in this field. And one number was pulled out of the environmental report, which kind of struck me, and that is 2,100,000 gallons, 2.1 million gallons of radioactive wastewater would be discharged annually from this plant into the Broad River. This is an average number over the lifetime of the plant, 2 million gallons per year. The rate could be as much as 50 times higher, according to the environmental report submitted by Duke Energy. That is if there is no accident and nothing bad happens. But what I really want to talk about today is the reactor which Duke Energy plans to build. And this is a AP1000 Westinghouse reactor. The reactor that Westinghouse has designed and that Duke has selected is supposedly an inherently safe design. In order to make the reactor cheaper to build and simplify, they eliminated a lot of pumps and piping in order to bring this design to fruition. And what they have done is create, this is the containment building here that I've drawn. It's a dome-shaped structure, and this would be the power plant, the reactor vessel inside. There's also, at the top of this reactor, a water tank of about 800,000 gallons, which weighs about 3,334 tons, suspended on top of this reactor. Now, this reactor is a modular design. It's put together in pieces. And one of the Nuclear Regulatory Commission's own people reviewing this design came to the conclusion that because of the modular construction, again, another cost-saving measure, instead of casting it in one piece, it would shatter like glass, according to Dr. John Mott, because of the modular construction. In addition to that, I mentioned the water tank up here, which is supposed to provide gravity flow in case of the loss of power, which is what one of the principal things that destroyed the Fukushima nuclear power plant. So instead of having to pump water up from below with electric power provided by generators, you have a gravity-fed system. Well, that sounds good, but 3,300 tons of water balanced on top of a structure which itself, for example, the reactor core, the reactor vessel itself weighs about 400 tons compared to that over 3,000 tons of water balanced at the top of this reactor. You have an unstable situation because the reactor itself is not only modular constructed, which could shatter like glass, you also have a heavy weight at the top. This is not inherently safe. This is inherently dangerous. Another so-called safety feature is this. I've drawn a double shell here, and that is to, according to the design, allow air to circulate freely between the steel shell and the concrete shell on the outside. You might see that this air circulates out and then leaves the top of the reactor. This is an annular ring, it's called, which basically surrounds the whole structure. There's a gap in here, which is a departure from earlier designs, which had the steel and the concrete touching. What's the problem with this? So-called safety feature leads to new fundamental weaknesses, which have not been addressed in the licensing and the approval of AP 1000. And that is this. This steel shell inside is subject to corrosion. Dr. Rudolf Hauser has pointed out that this is not a good system because this paints and other corrosion protection features are only guaranteed for a period of about 10 years according to the manufacturer. Then it's up to who applies the paint to meet the regulations. So he recommended against the use of this entire construction method. What can happen here if you have an event within the reactor where there is an escape of radioactive steam filling up the building, and you have a gap anywhere in this shell, it would join the normal circulation of air like a siphon effect, sucking air from inside the radioactive gases inside that building through that annular gap between the steel and the concrete, exiting out to the atmosphere. A nuclear power vessel, a containment structure, is supposed to do that. It's supposed to contain it. So, this is the design which Duke Energy has proposed to use, Westinghouse has designed, the Nuclear Regulatory Commission has proposed, and which business leaders in South Carolina are apparently inviting in without question. This is the reactor. This is the danger which you are inviting in to Cherokee County. If no bad things happen, earthquakes in this region, which it's famous for, or some other type of internal disaster does not happen, you still have 2.1 million gallons of radioactive water being discharged, according to the company's figures, provided to the NRC. 2.1 million gallons of water if none of these events happen every single year into the Broad River. We oppose the environmental impacts. We oppose the public health impacts, as well as the problematic and dangerous use of nuclear energy in this part of the world. I think we should follow the lead of some of the most advanced technological societies on Earth, Japan, Germany, and phase these out, certainly not build a new one. Thank you very much.